Greetings, everyone. Welcome to the end of Unit 5. This is the last set of notes talking about Venn diagrams and talking about probability and odds. So we're talking about kind of the combination of what happens when things overlap, what happens when you're a part of more than one situation, and kind of what does that look like. So when you're talking about a Venn diagram, you're talking about this thing right here. Okay, and what this represents is this situation. So you have a total of 100 adults, and whether or not they like coffee or tea, and then the Venn diagram kind of shows the coffee. So 13 like coffee only, 25 like tea only, 46 like both, 16 do not like either. Okay, so person chosen at random, find the probability that the person does not like coffee. Okay, so does not like coffee. So that would be the tea drinkers only and the people that don't like anything. So that's going to be 25 plus 16 over 100. So that's 41 out of 100 or 0.41. So now you have a person who likes tea. Okay, so we're limited to those two. Find the probability that this person also likes coffee. So the probability that this person also likes coffee is going to be 46. Now, it's not 46 out of 100 because remember, we're only taking people that like tea. So it's going to be 46 out of 71. So that becomes 46 plus 25 is 71. That's going to be my answer right there. So two people are chosen at random. Find the probability that they both like coffee. So this is going to be a situation where you are going to multiply. So if they both like coffee, so that's 46 and 13. So it's going to be 59 people out of 100 like coffee. So then once I've chosen that person, I have to find another person that likes coffee. Sorry, not out of 100. That's right, taking away one person, that's 58 out of 99. So that's going to be 3,422 over 9,900. So that's going to be 0.346. So what are the odds that a person chosen at random likes coffee? So now we're back to odds. So we're like odds in favor of coffee. So remember, it's odds in favor over odds in favor of coffee over do not like coffee. So if 59 people like coffee, then 41 do not like coffee. So what are the odds that a person chosen at random does not like coffee and tea? So again, we're at odds. So what you're setting up is a ratio of who doesn't like coffee or tea versus who does. So there's 16 people that do not like coffee or tea. There's 100 people total, so I take 100 minus 16, so that's going to give me 84. So that is my odds that a person doesn't like coffee or tea. So if there's 50 people enjoy fishing, 22 of them like walleye, 15 like bass, 10 like both, so the sum total of this has got to be 50. So if this is kind of walleye, this is kind of bass, the overlap is both, so 10 people like both. That leaves 5 people that only like bass, and that leaves 12 people that only like walleye. And then that only adds up to 22 and 5 is 27. There's 50 people total. So that means 23 don't like either one. So what's probably a fisherman chosen at random fishes walleyes, but not bass? So that's going to be 12 out of 50. So that's going to be 0.24, 24% do like walleye, but do not like bass. So what are the odds that a randomly chosen fisherman does not fish for walleye or bass? Okay, so there's 23 people that don't fish for walleye or bass, which means that there are 27 that do. Okay, so this is the odds in favor and the odds against or in this situation, what we want to have happen and what we don't want to have happen. So 200 people at the Minneapolis Comic-Con, 152 of them like Star Wars, 75 of them like Harry Potter, 42 like both. So you're going to have a total of 200. You're going to have Star Wars, you're going to have Harry Potter, you're going to have 42 that fit into both, which means you're going to have, in the Star Wars, you're going to have another 110. That gets you up to 152. Then out of 42, you're going to have 33 more. That gets you up to 75. And if I run numbers out of 200 people, that means I have 15 people that don't like Harry Potter or Star Wars, okay? So they like other things. So what is the probability that a Comic-Con fan chosen at random is a Harry Potter fan? Well, Harry Potter is these two. So that's going to be 75 out of 200, or 0.375. So what is the probability that two people are chosen at random will only be Star Wars fans? Only be Star Wars. Well, if it's only Star Wars, that means I've got 110 out of 200. And then I've got 109 people left and 199 people left. And that is going to give me my probability. So yeah, I'm going to have a weird looking big number. So I'm going to have 11,990 on top, 39,800 on bottom. So that's going to be 0.301, or about 30% of that situation. Okay? So, same kind of situation. So I can redraw that quickly. So I've got Star Wars, I've got Harry Potter. So that was 42, that was 33, that was 110, and that was 15 that don't like either. What are the odds that they are a Harry Potter fan? All right, the odds that they are a Harry Potter fan. Well, 72 like Harry Potter. That means 125 don't. Okay, so simplified, that'd be like 3 to 5. So you want Harry Potter, and then you want non-Harry Potter. So if one fan is chosen at random, find the odds that they don't like either Harry Potter or Star Wars. So neither one, which is going to be this 15 down here. And then you've got 185 other people that do. So if I simplify that, that is 3 to 7. Okay, this concludes Unit 5. So please finish up the notes, finish up the review, and put together a DOK and get ready for your quiz.